Greetings and welcome, ladies and gentlemen. Today we're going to learn the value of knowing an inverse of a matrix. It turns out that matrices are going to be able to flashback, ready, here we go, solve systems, right? Way back at the beginning of this course, we learned how to solve systems. We talked about graphically, right? We solved them by substitution and elimination. We're actually going to use matrices to solve systems today, all right? And this is kind of the idea. Let's say, let's actually just jump right in here. How about, let's jump right in here. Let's say I've got the following system that I want to solve. 4x minus 2y equals 16 is my first equation. And x plus 6y equals 17 is my second equation. So you might look at this and be like, oh, I would solve this using substitution. I would solve for the second equation's x. Or you might be like, I could solve this using elimination method. And I'd multiply the bottom one by -4 to get opposite x's. Or I'd multiply the top one by +3 to get opposite y's, right? And you'd be able to do all sorts of stuff like that. Now, it turns out we can represent this with kind of a couple matrices, actually. Maybe even 3. Is what we're going to do. The first matrix, we'll call matrix A, is going to be our coefficients. So it's a 2 by 2 matrix, and it's just made up of our coefficients. So 4, -2, 1, and 6, right? So you see the coefficients of our x's and y's, and there are 2 equations right there. The second matrix is going to be our unknowns. This is a capital X, right? Matrices are named with capital letters. And there's 2 unknowns we're looking for. We're looking for little x and little y. Okay? And our third matrix, we'll call B, is going to be our right-hand side of our equations, or our constants. So in this case, that would be 16 and 17. Right? So just so we're aware, these are the coefficients. These were the variables, and these are the constants, or the right-hand side. And this is going to require that you have your matrices kind of set up in this order for it to work. Now, before we go any further, I just want to show you that it turns out that A times X equals B. All right? Matrix A times matrix X equals B. Is kind of the general starting concept that we have for this. Now, first of all, could I even multiply matrix A times matrix X? Are those multiplicable? What's the size of matrix A? 2 by 2. What's the size of matrix X? 2 by 1. Let's see, the inner numbers match. That's good news. And the outer numbers are 2 and 1. So if I multiply these, I should end up with a 2 by 1 matrix. And notice matrix B is a 2 by 1 matrix, okay? So it at least agrees size-wise, if you would. And even we won't normally have to do this. This is just kind of justification I'm building for you. Let's multiply A times X just to see what happens. So what is A times X? Well, I would multiply this row by this column, right? And I would get 4x minus 2y, right? And then I'd multiply this row by this column, and I'd get 1x plus 6y, right? And I just want to point out, I'm saying that ax equals b. If I set this equal to this matrix, then the corresponding elements would be equal, right? So this would equal that, and this would equal that, and this would in fact translate back to our original equation setup. Okay? So far all I'm talking about is kind of rearranging this into some sort of matrix form, and I just want to verify that this equaling B would in fact relate to the original thing. Alright, so knowing what matrix A, X, and B are going to be important. So now I'm going to justify some matrix algebra for us. Okay? And this is kind of a generalized concept for all of these problems. All right. So here's some matrix algebra. matrix algebra. So we're starting with this concept, matrix A times matrix X equals matrix B. Now, if I wanted to get matrix X by itself, it's currently being multiplied by matrix A, so what would you want to do to both sides of this equation to get X alone? Right, you'd want to divide by A. However, don't write that down, because we discussed how there's no such thing as division of matrices. So that's bad news. However, we do know the inverse of matrix A. All right, check this out. What if I multiply both sides by the inverse of A on the left? Okay, so A inverse multiplied on the left. Now, question, what is A inverse times A going to be? What do I get when I multiply any matrix by its inverse? 1. What was the quote-unquote 1 equivalent? What's the word we had for that for matrices? It's one of those I words. Anybody? From yesterday, we had inverses was one of them. That's what right here. And the inverse multiplied by the original gives us the identity. All right. So when I multiply these two, this is going to give me, it's actually in this case going to give me the 2 by 2 identity, but I'm just going to leave that as identity right there. And that's what I'd get. Right? So multiplying A by its inverse gives me the identity. Now, the identity matrix, which is 1, 0, 0, 1 for a 2 by 2, right? The primary diagonal was all 1s and everything else, all of the other elements were 0. What do I get when I multiply any matrix by the identity? Thoughts? If I multiplied the identity by matrix A, what would I get? Yeah, or if I multiply any matrix by an identity, what would it give me? No? Or wouldn't it be itself? Itself, yeah. So if I multiply matrix X by the identity, that's just the same as matrix X. So what I'm left with is that matrix X is going to be A inverse times B. And this fact is going to be the one that allows us to solve our system. Okay? So this is kind of the matrix algebra that we had to understand, because division did not exist, all right, for matrices. And notice if I solve for matrix X, then I would know its elements, and that's exactly what I'm looking for. All right? So let's see, 4, negative 2, 1, 6. So matrix A is 4, negative 2, 1, and 6. So in order to calculate this, what things do I want to find out? Yeah, so I know that this is a 2 by 2. I know matrix B already. What other information do I want to know? Yeah, let's find A inverse. How do I find A inverse? No. What were we doing last night? What did we do on? Let's find the determinant first. Okay. So let's find the determinant here. So 4 times 6 minus 1 times negative 2. Right? So that's 24 plus 2, or 26. So the fact that this determinant is not equal to 0 tells me what? There is an inverse. An inverse exists. So A inverse is going to equal 1 over the determinant, 1/26, multiplied by the following, right? I'm going to flip the primary diagonal, so 6 and 4. I'm going to change the signs of the secondary diagonal, -1 and +2. And in fact, I'm going to leave the inverse like this. All right, so here's A inverse. That's helpful information for us. And according to our little algebra, what is matrix X equal to? A inverse times B. So let's do that. So matrix X is equal to A inverse times B. And that would look like this. 1/26 multiplied by 6, 2, -1, 4. So there's A inverse. And I'm multiplying that by matrix B, which was it 16, 17? Yeah. So let's calculate this. So I'm going to deal with the 1/26 until the very end. Let's see. I've got a 2 by 2 multiplied by a 2 by 1. So I'm expecting a 2 by 1 answer. So 2 rows, 1 column. So I'm going to multiply this row by that column. So let's see. 6 times 16. Let's see. 60 plus 36, 96. Plus 2 times 17 is what? 34, I believe. That's going to be our first row, first column answer. And then I'll have -1 times 16 is -16, plus 4 times 17, 40, plus 28, 68, is it? Right? So let's keep going.
Please excuse the interruption. Roy and his students in Ms. Stopper, Mr. Taylor, Mr. Paper, and Ms. Mary's advisories. Please report to the TSN studio for your school.
58. And what? 52. So, what happens when I multiply this by 1/26 or divide each element by 26? I think 130 divided by 26 is 5, and 52 divided by 26 is 2. So that's matrix X, which tells me what? What was matrix X originally? What did I label that as? Yeah, put your variables. So little x is equal to 5, and little y is equal to 2. And there's our answer. Right? So that's the idea, is this A inverse B will always give us the solution to a system in which matrix A was the matrix composing of the coefficients, matrix X was our variables, X and Y, right? And matrix B was the right-hand side, or the constants. All right, so all I have to do is figure out what's the inverse of A and multiply that by B, and I get my answer. All right, so you won't normally have to do all this or this, all right? You just have to know this fact, bam. And then this is the work that you would do. All right, so we're going to do another example, but I think the next example we'll do is going to be even better. We're going to do a 3 by 3. All right, because you guys did not enjoy solving 3 by 3s back in the day, if I recall. Solving those by hand, no es bueno, right? So let's see, here we go. Let me give us a 3 by 3 matrix. What if I've got x plus y minus z equals -1? I'll have x plus y plus z equals 3. I'll have 3x minus 2y minus z equals -4. All right. So, this is what we got. First of all, tell me what matrix A would be. Actually, what size would matrix A be in this case? 3 by 3, because there are 9 coefficients altogether. So it looks like 1, 1, -1 would be my first row's coefficients. 1, 1, 1. Friendly numbers so far. 3, -2, -1. What would matrix X be for us? 3 by 1. Little x, little y, little z. And matrix B negative 1, 3, negative 4. So according to our little matrix algebra we calculated earlier, what do I want to figure out? I want to do x would equal what? A inverse times b, right? So that's what I want to find out. X equals A inverse times b. Let's see. Actually, what I'm going to have you guys do, there's some yellow calculators up at the front of the room. I'm going to have you go grab those real quick. And I think there's only 2. So here is another one. Oh, that battery's dead. Bam. All right. Here we go. So what we're going to do is enter in our matrix information that we did earlier. Right, I taught you how to do that a while ago. We're going to do that together. So I'm going to have you follow along on this calculator right here. Bam. All right, so here's my calculator. I'm going to turn it on. Bam, it's on. So first thing we're going to do is edit our matrices. Matrices. Here we go. So, all right. So I'm going to hit the matrix button, which is right here. So to access that, I hit second matrix right there. And I'm going to go over to edit. And let's edit matrix A. And matrix A in our case was what size? 3 by 3. So I'm going to change that to 3 by 3. And now I'm just going to go through all of these elements and plug in these. 1, 1, negative 1. Right? So 1, enter, 1, enter, negative 1, enter. For the negative 1, make sure you're using this button, the negative symbol, and not the subtract symbol. Okay? Those do count as different things, and your calculator will cry, and it won't like it. And then let's see, the next row, 111. So 1, enter, 1, enter, 1, enter. No? Second matrix. And then scroll over to edit on matrix A is what we're doing. Yep. And now the last row is 3, negative 2, negative 1. So 3, negative 2, negative 1. Bam. All right. So I've entered all the values for matrix A. Check. Let's see. What other matrix do I need to know? Matrix B. So let's do that. I'll go back and hit second matrix. Hit second matrix.
So it's negative 4, isn't it, for the last row? Last
3, negative 2, negative 1.
Oh.
For this one. Yeah.
And then you put in 1 by 0.
Yeah, so let's go over to edit and matrix B. We'll do 3 by 1. And now the elements we're going to enter here are negative 1, 3, negative 4.
So how do you make it for that?
At the very top, you type in those numbers.
It just goes to some weird thing.
Did you go to the edit menu again? So to change the size here, it's at the very top. Yeah, so you can change those numbers. 31. So you can change those, and then we've got negative 1, 3, negative 4.
Ah, but matrix C, is that right?
It doesn't matter if you use a different name matrix, just you'll have to remember which one was named what. So now that I've got both of those named, let's quit out to the home screen, which is blank. So second quit does that. Little quit button right there. And I'm going to actually do my calculation. What calculation do I want? I want to figure out A inverse times B. So to get matrix A up, I hit second matrix. And under names this time, I'm just hitting enter on matrix A. All right, so now matrix A shows up on the home screen. To do inverse, check out how nice this is. The inverse icon is the button we've been hitting to get to the matrix menu. We're just not going to hit second this time. So here's A inverse. Actually, you know what? Let's time out here. Let's just hit enter and find out what is the inverse of A. And there's A inverse. Actually, I'm going to even snapshot that and throw that into my notes. Paste. So here's the inverse of a 3 by 3 matrix. Okay, I haven't shown you how to find the inverse of a 3 by 3 matrix. Yet some of you have more decimal points showing than others. If you use the arrow keys left and right, you can scroll around to see the whole matrix if you wanted. But I just want to point out, this inverse exists, first of all, which is good news to us. You could actually have told me whether the inverse existed by calculating the determinant. And if the determinant was anything other than 0, you would have known that an inverse existed. But we don't know how to find the inverse of a 3 by 3. That's fine. You don't have to. Our calculator will do that work for us. And in fact, your calculator could find the inverse of a 4 by 4 or a 5 by 5 or a 10 by 10. And you could solve some pretty fancy problems for yourself if you really wanted to. So let's go back to the calculator here. So I want to do, check this out. I'm going to hit second button. And watch this. Instead of re-entering A inverse and all that, I'm going to hit second, and the enter button has this entry right here. And what that does is it re-enters whatever your previous row was. So that can kind of be a nice little shortcut, especially if it was a long thing and you just wanted to edit like a single portion. So let's see. I want to do A inverse times what? B. So second matrix. And this time I'll select matrix B, or matrix Z, or whatever you said you made yours, right, for your 3 by 1. And now I've got A inverse B showing up here, and I'm going to hit enter. Here we go. And in fact, I find my answers. Behold. Let's see, paste. So here's A inverse B, which tells us that X, so let's see, I'll actually write that down. So capital X is equal to A inverse B is equal to this 3 by 1, which is 0, 1, 2. Kind of easy right there. Which tells us, if I translate that back into little lowercase letters, that means little x is 0, little y is 1, and little z is 2. Or I could even write that as an ordered triple, 0, 1, 2. Where that is the intersection of 3 planes, the one solution common to all of them. All right, so your calculator can do some matrix math, which is pretty nice. Whenever we have a 2 by 2 system, I'm going to have you do those by hand so you can practice the concept of inverses. You can still practice your multiplication of matrices when you do your A inverse B. But for 3 by 3 or more, you can do it on a calculator. You could also check your work, I guess, using the calculator when you're doing a 2 by 2. But I do want to still see your work done out by hand for those 2 by doses. So I think instead of doing more examples, I think I'm just going to stick to these 2 for this video. But the big idea is solving systems using matrices and memorize this guy right there. Bam, good stuff to know. So, all right, Internet friends, thanks for watching. Bye-bye.